Hi there. Gonna make a quick video here for you guys to watch how to solve rational equations. Um, we are hopefully enjoying some wonderful weather at Worlds of Fun. I'm sure I'll have lots of pictures to show you guys on Tuesday when I see you again. So we're going to be working with these rational equations, and today is just going to be kind of some simple ones. And then on Tuesday and Wednesday or Thursday, we'll be going over the more difficult graphing and the more difficult solving equations that we need to kind of wrap this unit up. So the first couple problems we're going to do, we're going to use one method, which only works for problems that are kind of set up the right way. Look at the first two examples here. I'll flash the second one real quick. If there's just one thing on each side. And that method would just be cross multiplying. So some of you guys should be pretty familiar with. So I'm going to be multiplying these two here, and then I'll multiply these two here. So when I multiply the 3 times the x minus 7, and then remember that doesn't create a new fraction, it creates a new equation. And then we take the 5x times the 2. And of course, we will need to distribute when we do this. So it is something you need to be kind of looking out for. So of course we get 3x minus 21 equals 10x. I'm going to go ahead and solve this. So I'm going to subtract 3x from both sides. That'll give me negative 21 equals 7x. And then divide by 7. So x equals negative 3. So pretty simple. I'm going to go ahead and check that. Always want to make sure. We've talked a lot about the domain of these equations when we were doing the graphing, so I just want to make sure that our answer is actually in the domain. And where anything that's going to go for be a problem there is with if we make that denominator 0, we could end up in issues. So plugging in negative 3 into both x values here. So so that gives me 3 over negative 15 equals 2 over negative 10. Remember, we're just supposed to be reducing or simplifying each side, so that gives me negative 1/5 equals negative 1/5. So it works out. Okay, so negative 3 is the solution there. Okay, so we'll go into the next example, which will end up is set up the same way. It only works when there's one expression or one one ratio or one fraction on each side. So when it works, one term on each side, one fraction on each side. So I'm going to go ahead and cross multiply here. So multiply those, and of course you can do a lot of distribution in your head. So it's 1 times 11x plus 8 would just be 11x plus 8. And that's going to equal, it's on x times 2x, 2x squared, and then x times 5 would be 5x. So make sure you're distributing. So I'm going to notice here that I have a quadratic, so I'm going to move everything to one side, and I want to keep that that quadratic term positive, so I'm going to move everything to the right. So it's going to give me 0 equals 2x squared minus 6x minus 8. I'm going to go ahead and divide 2 out of everything, since I do see that I have a 2. And because it's an equation, actually, you just get rid of the 2, since it's going to go over to the left side. If it was an expression, that 2 would have to be on the outside of the parentheses. We can do some AC. Maybe shortcut AC. So our AC is negative 4. We need to add that to be negative 3. That would be positive 1 and negative 4. So 0 equals x plus 1 and x minus 4. So that means x equals negative 1 and x equals positive 4. So I will have to check both those answers. So I'll check -1 first. So check -1. So 1 over 2 times -1 plus 5 equals -1 over 11 times -1 plus 8. So remember, just simplifying each side, so we get 1 over -2 plus 5, -1 over -11 plus 8, and then that would give me 1 over 3 equals -1 over -3, which of course would simplify that, so looks like -1 works. And then checking 4. It's going to give me 1 over 2 times 4 plus 5 equals 4 over 11 plus 4, or times 4 plus 8, which should be 1 over 8 plus 5 equals 4 over 44 plus 8, 1 over 13, 4 over 52, and 4 and 52 both have 4 in them, so it would be 1 over 13. So they both work. So cross multiplication is a pretty simple way to solve these problems. But again, it only works in certain case where the problem is set up like this. One term on each side. So on Saturday, we took Nola to this event down at Broken Arrow Park, which was called Touch a Truck. And they had all these sorts of different trucks and construction equipment and stuff there. They also had a lady that was making balloon animals or balloon objects. So Nola got a balloon princess. It was pretty cool to watch her make this intricate balloon. They also had like balloon mermaids and wands and stuff like that for girls. So that was pretty cool to see that. Nola was very happy to have her balloon princess. And then here she is in a backhoe. And this is before she was hitting all the buttons and whatnot. She also got into like a cement mixer and just like a semi truck. Thought it was pretty funny to pull the the big horn. So it was pretty cool to see her jump around, getting in there and mess around. To the next set of problems where there's multiple problems, multiple expressions on each side, multiple terms on each side. This method does not work. So, all right. So the other type of problem that we're gonna look at, so it has multiple terms on each side, so we can't do the cross multiplication. So what we're gonna end up doing is gonna be finding the LCD and multiplying by the LCD to basically cancel out the denominators. So this method works all of the time, whether there's multiple term or multiple terms on each side or just one term on each side. So so it is a more useful method. But again, that one's so easy to do that it's kind of nice to be able to take advantage of it when we can. So I want to think about what do we need to multiply each fraction by in order to get the denominators to be the same. And so just kind of looking at the denominators, I want to go ahead and notice that these two are the same, so I don't need to worry about getting them to be equal. But that middle fraction here does have a different denominator. So you want to think about that. So what does the x denominator have that the 4 doesn't? So it'd be an x. So I want to give one thing about okay, I give that an x, and what does the x denominators have that or not have that the 4 does, which would be of course be the 4. So if I could make them all 4x, they would be the same. And so we're actually not going to we're not actually going to make them the same. We're just going to figure out what that LCD is so that we can multiply all the terms by it. So now that I know that it's 4x, what I want to do is basically multiply each term by 4x. So it's a little tricky to write, kind of squish it all together. So you kind of need to watch how you're writing as you do this. And the point of this is to be able to cancel things. So you notice, that the x here is dividing, and so then this x here that we're multiplying by they're gonna cancel each other, and so that goes away and that goes away. And so what that leaves us with is just the 4 times the 5, so that's a 20. And then we have our plus, and then here the 4 and the 4 cancel, and so that leaves us with this 7 times x, so 7x. And then we have our equals sign, and then on the last term the x's cancel again, and what that leaves us with is watch that negative, so it's negative 36. And then we just have this nice little easy equation to solve. So I'm going to subtract 20 from both sides, so that's going to be 7x equals negative 56, and divide by 7, so x equals negative 8. So I'm going to check that. So 5 over negative 8 plus 7 over 4 are supposed to be negative 9 over negative 8. So notice on the left side I do have a common denominator to try to get. Sorry for my phone going off here. So I'm going to multiply there by 2. Actually, yeah. So that's going to give me negative 5 eighths plus 14 eighths, which is going to be negative 9 eighths. Nope, positive 9 eighths. Negative 5 plus 14 is positive. And then on the right side, well, I just have these two negatives, and those are going to reduce out. So that would reduce down to positive 9 eighths as well. So negative 8 works when we plug it in. Check. All right, last example. So notice again that this is the same thing where we have multiple terms on one side, so we can't just do the cross multiplication method. I'm going to go ahead, and since I do have one of the numbers not written as a fraction, we'll go ahead and write it as a fraction. And then I want to think about what that LCD is going to be. So, of course, the 1 is not going to change anything as far as the x minus 5 and the x. The 1's not going to change those. So it's more about thinking about what does the x minus 5 have that the x doesn't, what does the x have that the x minus 5 doesn't. So remember, x and x minus 5 cannot be multiplied by anything to get them to be the same, so we just end up multiplying them by each other. So I would multiply that by that, and so I notice that these two denominators are now the same. They both have an x and an x minus 5, and so that the 1 would also need the x and the x minus 5. Okay, so there's our LCD, is x times x minus 5, and I'm not going to distribute that. It's actually a little more helpful when we don't. So I'm going to erase all this work that I did here. And so then what I want to do is go ahead and again multiply each term by that LCD. Again, this one's a little trickier to write. But okay, so just kind of get them in there however you need to. And then the idea here is to go canceling. So I'm going to start on the right side because there's something to cancel. So just noticing that those x's will cancel. And so what I need to worry about now is the 3 times the x minus 5. So we'll have some distribution to do there. So that would be 3x minus 15. And then in the middle here, the x minus 5s will cancel. That's going to leave me with 8x. And there is a minus sign there between those, so I'm going to put that minus sign in front of that. And then on the far left, there's nothing to cancel, so those are just all going to multiply each other. Of course, the 1 isn't going to do anything for our multiplication, so I just need to worry about the distribution here between the x and the x minus 5. So that's going to be x squared minus 5x. So again, I'm noticing that I have a quadratic, so I want everything to be on the left side. So, but first, before I get to that, I'm going to go ahead and simplify the left side. So x squared minus 13x equals 3x minus 15. Now I'm going to bring everything to the left side. So subtract 3x and then add 15. That's going to be x squared minus 16x plus 15 equals 0. Some AC method. So our AC is 15. We need to add that to negative 16. That's going to be -1 and negative 15. So write that, x minus 1, x minus 15 equals 0. So x is 1, x is 15. So the last thing I need to do is check those. So we'll check -1 first. So 1 minus 8 over -1. Oh, +1. Minus 5 equals 3 over 1. You can just simplify each side. So I have 1 minus the 8 over -5, -4 equals 3. So here here these double negative right here is going to give me a positive, and then of course 8 divided by 4 is 2, so we 1 plus 2 equals 3, which of course it does. So the 1 is all good. And then checking 15. 1 minus 8 over 15 minus 5 equals 3 over 15. So 1 minus 8 over 10 equals 3 over 15. So there are 10 tenths in 1. So that'd be 10 tenths minus 8 tenths would be 2 tenths, which is equal to 1/5. And then, of course, 3/15 reduces down to 1/5. So they both work. Weird, I guess this little thing over here got. Well, that's fun. Let's see if we can erase that. So both solutions worked. So we did not see any examples of extraneous solutions here. But again, the idea with that would be generally the denominator becomes 0 with those. And then we, since we can't divide by 0, we have to say that solution would be extraneous. So hopefully that's pretty clear. Again, hopefully this problem should be pretty simple to do. Some easy factoring, checks, just some fractional work, so just be careful about that. But make sure you're checking solutions and just have a few problems to practice for tomorrow or for block day. I guess we'll probably do the graphing tomorrow, and then we'll finish up the solving on block day. So, all right. Well, I hope you guys have a good Monday, and I'll bring lots of pictures to show you guys from Worlds of Fun. Take care.